Hello there. Welcome to Object-Oriented Programming through Java. In this part, we will understand some of the object-oriented principles before we get on to Java programming. First of all, we need to understand what is an object. An object can be any real-world entity like a laptop, a chair, an animal, the sun, bank, or a car. In fact, simply to put, any entity can be an object. Let's take an example. Car. What do we know about a car? Its make, model, year, color, trim, etc. We can call these as the attributes that we know about a car. Likewise, what can a car do? It can start, stop, apply brakes, open the trunk, turn on the wipers, or turn on the moonroof, etc. So these are called as methods or operations. Take another example. An account. Remember, an object need not be a physical object. It can be any entity. It can be an account. It can be an organization. It need not be a physical entity. Like what do we know about an account? Account number, account holder name, balance, interest rate, address, etc. Again, we can call these as attributes. And what can we do on an account? Deposit, withdraw, order checks, change address, change phone number, etc. Also, we can call these operations or methods. So, if we look at a high level, an object has some attributes and certain operations that we can perform on those attributes. To better illustrate, consider the same example car. It has some attributes and some operations. The attributes are like engine, brakes, trunk, wipers, etc. And the operations as listed here: apply brakes, start, stop, open trunk, any other operations. Now, for example, if we do start operation, it's going to change the status of the engine. If we do stop, it's going to go stop the engine. So, what do we understand from this? The operations can alter the state of the attributes. In other words, operations affect the attributes. What is a class? See, there are several types of cars. All these are objects. How do we classify them? We can classify all of them as cars. Likewise, all these are animals. We can classify them as animals. So what is a class? A class is nothing but a blueprint of a particular classification of objects. For example, all the classification of cars, the objects cars, can be classified into a class called car. In other words, an object belongs to a class of objects. An object is an instance of a class. For example, my car, Peter's car are instances of a class called car. My cat, Peter's dog, somebody else's lion are instances of a class called animal. So to better illustrate what's the difference between class and an object, and to understand them better, take a look at this example. So like I said, car or any class is a template or a blueprint of that class of objects. In this case, here is the template of a car. A car will have year, make, model, color, etc. and operations such as start, stop, open trunk, and all other operations. Now, Peter's car is a specific object or a specific instance of car, which is 2010 Honda Accord with green color. And Victoria's car is another object of this class car, which is 1995 Nissan Altima, which is red color. Likewise, another object called Lisa's car, another object called Mike's car, and so on. You can create as many objects as you want from the same template or same blueprint called class car. So all these objects belong to class called car. In other words, these are the instances of class called car. Now, what is encapsulation? We know that there are attributes. As we understood, the operations affect the attributes. So, attributes are encapsulated by operations. So, what are we achieving by this? We are hiding the data, or we are abstracting the data around the operations. So, this is called data-centric approach because data or the attributes are in the center and the data itself is accessed by different operations. Another term often we can hear is abstraction. Abstraction means show only the necessary details and hide the other details. For example, start operation in the car. The start operation take a driver. For a driver, a start may be simply turning the key, invoking the start operation. But what goes on under the trunk? We don't know. So under the hood, there are so many things that are happening to make the start operation work. But all those details are hidden from the user. This is called abstraction. Inheritance. As we understand normally in our day-to-day life, even in object-oriented programming, inheritance has the same meaning. In our example car, a car is inherited from a general classification of vehicle. In other words, car is a vehicle. But what are the other types of vehicles? A bicycle is a vehicle. A truck is a vehicle. Likewise, there are so many other types of vehicles. All these inherit from a very generic classification called vehicle. Likewise, a car can be further classified into SUV, small car, minivan, etc. Therefore, these subclassifications inherit from a class called car. So this is inheritance. What is polymorphism? Poly means many. Morph means form. Therefore, polymorphism means many forms. Example, when I say my vehicle, it can be my SUV, it can be my mud bike, it can be my truck. So at vehicle level, I am very generic. It can have any one of these forms. This is called polymorphism. We can understand better about polymorphism when we do some of the Java programming concepts. Object relationships. When you take two objects, there may be certain different types of relationships between the objects. For example, association. Any relationship between objects is called association, which means there is some kind of association between those objects. Likewise, inheritance, which we already learned, it is a relationship. Aggregation means has relationship, which means object A has object B. Composition is also a has relationship, but it is a stronger form of has. We will understand about these little more in the further section. Association. Like I mentioned, take for example car, road. There is an association between these two objects. Car uses road. That is association. Take this example, aggregation. A car has seats. A car has engine. A car has steering. Car has headlights, tires, etc. This is called aggregation. Composition. Like I said, composition is also a has relationship, but it is more stronger. In this example, a building has multiple rooms. So we can say a building has rooms, but rooms cannot exist without building. In other words, if building is removed, rooms are also removed. Let us recap what we learned so far. We learned what is an object. Anything or any entity can be an object. What is a class? A generalized, a classification of objects or a blueprint of a certain type of objects is called class. Encapsulation. The fact that the data is encapsulated with operations, it is called encapsulation. Abstraction means hiding the unnecessary details or showing only the necessary details. Inheritance. As we know, it is a relationship. Polymorphism. Having multiple forms is called polymorphism. We understood different relationships: association, aggregation, composition. Now let's do an exercise. From the below paragraph, identify classes, objects, and their attributes and operations. Specify the relationships between those classes. Also, list what additional attributes or operations may exist in those classes. In XYZ University, there are several departments. Each department has multiple courses offered. Each course is opted by multiple students. Steve opted for Java programming course in computer science department. Stella opted for organic chemistry course in chemistry department. Also, the university library has many books. So, identify what are the different classes you can find in this paragraph. Also, different objects and operations, attributes, and the relationship between the classes. For example, university is a class, but XYZ University is an object of class called university. Likewise, department is a class, and computer science department is an object of class called department. Chemistry department is an object of class called department. So follow the example and identify all the classes, attributes, operations, and the relationships. Hope you enjoyed this lesson. We will learn more about Java programming in future sessions. Thank you for listening.